This is the video for Lesson 4.1, Identifying Linear Functions. We're going to start by defining a linear function. This is a function whose graph forms a straight line. So all three of these graphs are examples of a linear function because all three have a straight line that has been graphed. There's no curves or bends to the graph. It is a straight line. Something to take a note of is that linear functions have a constant change in both x and in the y values. So in this example of something that is linear, we see that constant change. The x's are all being increased by 1, and our y values are all decreasing by 3. When something is not linear, we find that there is a different change in either the x or the y's. Here it's not the x's because they're all increasing by 1, but we see that there is an inconsistency in our y values. They're not all changing by the same increment. Some are -3, -1, +1, +3. So since all of those are different, that function is not linear. So in this example, we're going to determine if the following represents a linear function. So if we look at our x from 2 to 5, that's an increase of 3. 5 to 8 is an increase of 3. And 8 to 11 is an increase of 3. So our x values are good. They have the same increase. Then we check our y's. 4 to 3 is subtracting 1. 3 to 2 subtracts 1. And to get from 2 to 1, we subtract 1. So there's a constant decrease in our y values. So yes, this is a linear function. The change in the x's is all the same, and the change in the y values is the same as well. Here's one for you to try on your own. Determine if the following represents a linear function. A linear equation is any equation that can be written in standard form. Now, standard form is ax plus by equals c. So even though the equation might not start off in standard form, like we see y minus 2 equals 3x, we can move the y and the 3x to the same side, so we have 3x minus y equals -2. There's ax, by, and c. So as long as our equation has both an x and a y, we are able to write in standard form. When things are not linear, we see x and y together, or we see an exponent on our variable, or our variable is in a denominator. So we want to determine if this function is linear. So our goal is to write it as ax plus by equals c. So our goal is to see first, do we have an x and a y? And the answer is yes. And now we're going to try and get the x and the y on the same side. So to do that, we're going to need to move the x over to the side with the y. Well, as we've seen in lessons 1 and lesson 2, to move anything to the other side, you use the inverse operation. So we're going to need to, if we were to split this equation in half, subtract x from both sides to cancel it out on the right, leaving us now -x positive y equals 3. And now we have our ax plus by equals c. If we were to look, a has a value of -1, b is +1, and c would be 3. So yes, this is a linear function. Here's one for you to try on your own. Tell whether the function is linear. So your goal is to see, can we write this in the form ax plus by equals c? At this time, you can leave your question for lesson 4.1. This concludes our video for lesson 4.1.